Okay. So back to lesson 3 real quick, just to make sure that we've got some of the details and that we're ready to go, especially since I forgot to record on Friday. Totally my bad. So here we go. Now, you guys in front of me, this might be super easy. Okay, so just soak it up, make sure it all kind of clicks and you all remember it. But what we start talking about, obviously, all of chapter 2 is all about normal distribution. So we're going to see that bell curve every single time. And the way that we figure out what's going on is that the middle will always be, what's that? Mean, good, nice. That's the average right there. Perfect, right? That right there, there's your, I'm going to say mean, because that's technically even better. Good, we know what mean is. What is that symbol? Remember which one that is? Remember the name of it?
No, I really don't.
Do you remember this one?
That's what I'm looking. I don't remember the names of them. I remember the sigma.
Nice. The top one's sigma. That represents standard deviation.
Did you find it, Stephen? No, you could not.
So that one's sigma. What's the bottom one? The weird looking U. Nobody? Mu. Mu. That's your mean. Mu, mean, M. Standard deviation, sigma, SS. That's on purpose. And so always, right down the middle is always going to be your average. And then each of these tick marks going to the right is just going to be plus a standard deviation, then plus another one, then plus another one. Going to the left, minus a standard deviation, -1, and then -1. So we get like 1 through 3, and -1, -1, -2, -3. And what it does is it breaks up 100% of the data is under that curve. All of it's going to fit in there somewhere. It's called the 68, 95, 99.7. So what happens is between here and here is 68%. From here to here, so like plus or minus 2, 95% of the data is going to be in there. And then 3, all the way from there, all the way to there. That, all of that's going to be 99.7. Okay, so only like you have this tiny little piece over here, this tiny little piece over here that doesn't fit, plus or minus 3 standard deviations. Those are like your outliers that we have, right? Any really big ones or small ones. This only works for normal data. It's only for data that's normally distributed. And so what that rule does, the 68, 95, 99.7 rule, what that does is it helps us break up these chunks, these slices, right? These two middle slices, half of 68, so that's a 34 right there. That's a 34 right there. Okay, just from there to there, there to there. And you're going to see why this is going to be really helpful for us as we build towards something bigger. But we just have to learn this part first. What were the next two smaller sections, just like here to here? 13.5, okay. Because we take like the difference between the 95 and the 68, and then we cut that in half. So that's 13.5, 13.5, just in there. So each little section has its own percentage of the data that it kind of represents. What's the next little section? Pretty small. We only have like this little piece. 2.35%. Tiny, tiny, tiny. 2.35%. So middle ones are the biggest ones, and that's why they're the tallest, right? Then smaller and smaller and smaller, and then you've got this tiny little section to the left of there, and this tiny little section to the right of there. That was like 0 point something, right? 0.15%. That's not 15%, that's 0.15%. Super, super tiny, less than 1%. And those are the numbers that we need to keep going. Okay, and so that's all I'm going to focus on with lesson 3. Let me get you guys lesson 4 while you're sitting here. Folks at home, I'm going to get this to you tomorrow. You don't have to print it out, but I think it's going to be way easier.
Are we turning all of these in?
Eventually, yes. Yeah, for sure. Now, what I just gave you is actually lesson 4 and lesson 5. So that'll be good for you guys tomorrow, too. So you don't have to worry about printing anything out. And it also includes, so there's 3 pages. First page is lesson 4, second page is lesson 5, and then the third page is what we'll use in lesson 5. So don't worry about that until you get there. But for now, folks at home, this is really a lot about how comfortable you guys are. Obviously, this is not me making this stuff up, right? This is something that people way smarter than me came up with to figure out how data that's normally distributed can be kind of spread out. Any questions in anything that is written right now? Okay, you really only have to worry about two things, right? What's the average? And then what's the standard deviation? And guess what? We never have to calculate that standard deviation by hand again until maybe like we get to like a final project kind of thing and start from scratch. You guys here all good? You don't have to have those memorized necessarily, you just have to be able to find them. Okay, so having that lesson 3 handy, I think is going to make things really nice. And so what we do is we can design, and I'm just going to go through this first one again so you can see it. We can design our own bell curve using the two numbers they're going to give us, the mean and the standard deviation. Right? The mean always goes in the middle. And then every tick mark is just like for this one, +2, plus another 2, plus another 2, -2, minus another 2, minus another 2. It just kind of breaks things up into easy to find chunks, right? So bottom of page of that first page in lesson 3 looks like that. So when I get to lesson 4, you know why we're doing what we're doing. So any questions at home? Are we good to move? We're good? Okay, cool. I'm happy to go through lesson 3 when you guys get back tomorrow, in case you need it, okay? But let's use these ideas with lesson 4. Okay, so let's do it. Lesson number 4 uses these ideas, okay? And lesson 5 is going to use those ideas. So we're building, 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 building. Okay, lesson number 4 is about something called a z-score, okay? Every single point that's part of that data has its own z-score. And what it does is it tells you, and so I'm going to look at this third bullet. That's probably the most important one to tell you what we're going to get. It tells you how many standard deviations a point is away from the mean. So you've got, you know, everybody all lined up and you want to figure out, okay, like let's go to like person number 73. How far away are they from the mean? And how many standard deviations are they? Are they 1? Are they 2? Are they 3? Are they -1, -2, -3? So there's gonna be positives and negatives for sure. Okay. Obviously, the further away you are, the bigger your z-score. Okay. The closer you are to the mean, the smaller. And it's what's really, really nice is how simple the formula is. Super, super, super simple. Take your number, subtract the average, see what you get, divide it by 6. Divide by the standard deviation. So there's only 3 things we need. I need the value, whatever it is. So like go to the 73rd person, we're talking about height. How tall are they? Compare that to the average person. So we'll just find their difference. And then we'll divide by standard deviations. And what it does is it gives us how far away they are from the average. Are they the average? Are they 0.93 standard deviations away? We're going to get some decimals. So definitely calculators for sure to help us out. So what have we done so far? We figured out like what standard deviation is all about, right? Then what did we do? We kind of played around with what that normal curve looks like with those standard deviations. Lesson 3, we said, okay, let's actually draw this thing out, see what we're looking at. Now with lesson 4, what we're trying to do is figure out, okay, I've got the whole picture. I know what everybody looks like. Let's just look at one of these people, one of these, whatever the data is that we're studying, and let's compare them to the average. Okay, so take a look at number 1. And I swear, I'm going to do this over and over and over again. That's your z-score. Okay, but I have to draw the picture first. And so being able to figure out what goes where, I think is going to help us realize where people kind of fall within this bell curve. Or whatever it is we're looking at, right? So what always goes right down the middle? What number? Don't even look at the numbers up here. What always goes in the middle? The average, good, yeah. Okay, the mean is 24, so I'm gonna put that number right there. So step one will always show a picture, then step two will calculate the z-square. Okay, so now we're into lesson 4. Again, the z-score is telling us how many standard deviations a certain value is away from the mean. And then tomorrow, we can use that. So we're going to evaluate the z-scores today, and then we're going to use those z-scores tomorrow. Okay, let's fill out the rest of this picture, though. So remember, the average always goes in the middle, and then we use whatever the standard deviation is to go plus a standard deviation, then another, then another. So I'm going to say, okay, 24 is my average. Standard deviation is 2. Okay, let's go up 2. And then up another 2. That's cool. Back. There you go. You son of a gun. Let's see if I can find. There. That's pretty good. And then another one. So 24, 26, 28, and 30, and then going down to. As these numbers get bigger, I'm probably gonna have to tilt them so I can fill them all in. You'll see that when we get to like number 2, number 3. So that's like everybody. Every single person is under this curve somewhere. And most of them fall between 18 and 30, right? 99.7. So there's the average. Remember, 68, 95, 99.7% of the population all fall within those. So 68 fall between 22 and 26, 95 between 20 and 28, and then 99.7 between 18 and 30. But I don't care about everybody. The thing about a z-score, it's all about one single individual. Whatever we're studying, we look at one of them. Okay, that is your value. That is what I care about comparing to everybody else. The z-scores is kind of the basics of studying normal distribution. So this is going to be really good for you. And this is like AP Stats does this stuff. So you guys are way ahead of the game compared to maybe where you realize. So here's all we got to do. Take that number, okay, 27. Subtract the average, okay, 24. And divide it by whatever the standard deviation is. So they said the value, let's call it X because it could be whatever. And then the average, so mu, and then over sigma. Let me just see what we get, right? We'll do the top part first, of course. We got to put those numbers together on top. So here, let me switch colors. So I got like a step. I'm going to do a step of work here. 27 minus 24 is 3. And then we're always going to write the decimal. 1.5, perfect. Okay, and the reason why we're going to write the decimal, you guys at home can't see it yet, but look at the back, like the very, very, very back of that piece of paper. Table's full of decimals, right? So we're going to use those. Okay, so if it was 3/2, I wouldn't exactly know where to go. And we're going to learn how to read that table. And that's actually, sorry to make this even worse. Take a look. Look at me for a second. That's only half the table. There's the bottom half. Those are all the negatives. Those are all the positive z-scores. So negative z-scores, positive z-scores. It helps us just find probability. Okay, it helps us figure out where we're at. But that's it. All we have to do is stop right there for now. Now, if we had to round, I got to put this somewhere big. If you're going to round because you have to, always, always, always 2 decimals. Okay? If and when we get some weird fractions, this doesn't work out as nicely as we wanted, like 1.5, 2 decimals. And you can see, you'll see in that, it's called table A. We'll start using that tomorrow. 2 decimals. But today, that's it. Value minus mean over standard deviation. But being able to kind of like practice drawing out the bell curve is super helpful. Let's keep going. Sweet, that's it. Super, super nice. When they give us all the details, all we have to do is draw the picture and calculate that z-score. Okay, and so what I do is I always find the average first, because that's always my middle. And so the way that like they decide to write this stuff out, who knows what order they're going to write them in, I have to find the average first. There it is. That average goes in the middle. Now that number is kind of big. I'm going to turn myself sideways as I write these numbers. Get a little tilt to them so I can fit them in there. I also like to switch colors. Help you guys out. Because, oh, geez, yuck. Where's my phone? I need a calculator. Right? Look at that standard deviation. It's not nice. 6.2. It is what it is. It's perfect. But I cannot add 6.2 in my head as comfortably as I might like to. So this is where I rely heavily on the calculator. And the thing that I like about my phone's calculator, I don't know if you guys can, I mean, obviously you guys know what it looks like, but like if I do 125, I don't know how well you can see what I'm writing, but plus 6.2, and I don't press, hold on, let me turn it this way. And I don't press enter, it gives me what that is, right? 131.2, okay. Now, why is that so nice? Why do I care about not having to press enter? Well, then I just do it again, plus 6.2, and it gives me the right answer again, 137.4. 137.4. Hey, what's up? Is that for me? Oh, I always wanted a hyperflash. You're the best. Yeah, we're missing. I think a lot of people are online. Yeah. Thank you. And then do it again one more time. Plus 6.2. 143.6. What color am I in? Yeah. 143. Then I back it up and I just do the minuses. Minus 6.2. Okay, cool. 118.8. Always kind of building out from the average. And I do it again. You don't have to see it again, but I'm just going to do minus 1.6 again. 112.6. Minus 6.2 again. 106.4. Cool. So I use that. I use this. Always look for the average first. Then figure out standard deviation. A lot of times they'll just give it to us, which is really nice. But look, they didn't say the words. So we had to know that mu was the average and sigma was standard deviation. And then they asked the question, okay, what is the z-score? Okay, cool. So z equals, what are we doing? Where are we? Oh, we're right here. 104.5. Now take a look. Look at this for a quick second. Where is 104.5 on this list? Like way over here, right? Now, okay, so there's the average. There's minus 1 standard deviation, minus 2 standard deviations, minus 3. This is to the left of that. The z-score should be like less than -3, right? Because it tells you how many standard deviations you are away. Well, let's see if that makes sense. And that's kind of what we're doing. We're going to draw the whole bell curve, but we're just going to focus in on one spot. Okay, so 104.5. There's my number, right? It's always x minus mu over sigma. That's our z-score formula. 104.5. Sounds like a radio station. Minus 125 over 6.2. What's up, Jimmy? You're good, boy. Take one of these, and we are on 2. Again, I'm going to let the calculator do all this work. Now, I always put the tops together first just to see what I get. 104.5 minus 125. And you can come down here, it doesn't matter. So that's negative 20.5 over, that's a weird spot for that negative. I do. All right, so what's nice about this, they gave us everything. We just got to draw a picture out, right? And then we say, all right, this whole z-score thing, whatever the value is, minus the average over the standard deviation. If you mess that up, these numbers are going to be all over the place. So in my calculator, now I've got negative 20.5, and I'm going to divide that by 6.2. Oh, geez. Negative 3.306545. Yeah. Here's what that number looks like. I'm not going to keep all of it though, so don't write this down yet. But it like goes like that and keeps going. How many decimal places? Always, always, always. 2. Good. So I got to go to here. So I put like a brick wall right there in case you forget how rounding is going to help us make sure we get the exact right answer. We want to round it as best we can. So I know though, like the negative. So here's the thing: approximately equal to. So draw that little squiggly equal sign because we're going to round. I didn't have to with the 1.5 because it was perfect, right? But now it's negative 3.3, and then, all right. Well, the second decimal is a 0. But the one after that's a 6. So the question is, do we leave this as a 0 or do we bump it up to a 1? Right. We always look at that next one, right? 5 or above, give it a shove. So negative 3.31. And there it is, right? Remember, this was like -1 standard deviation, -2 standard deviations, -3 standard deviations, and now we're outside there. How did we know that? Because 104.5 is less than 106.5. So it kind of feels nice to be able to like draw that picture out and have the z-score kind of back that spot up. And I mean, that is definitely an outlier. Whatever this is, right? Whatever data we're looking at, okay, the average is 125. Standard deviation is 6.2. So not super big, right? 6.2. Most things fall kind of within 6.2 above or below. That's what standard deviation is. 104.5, way far away from 125 if the standard deviation is 6. Right? 118, 112, 106, 104 is even less than that. And what we'll see tomorrow is we'll start using these z-scores to like say even more about whatever 104.5 is. You know, we'll say, we can talk about what percentile they're in or what probability we are to kind of fall in that spot or whatever. There's a lot of different things. It's a pretty simple process, but as the numbers change and sometimes get a little bit tricky, sometimes that can mess with us a little bit. So I'm going to do one more with you, and then I'll give you some time to just try it out. I'm going to scroll. I'm going to do number 3. I got to get rid of the ink layer, though, because it just kind of follows me. And so here's the thing. You got to kind of slow down and make sure you find the average first. All right, so what is the z-score of the weight of a cow that tips the scales at 825 pounds? If the mean, there it is, if the mean weight for cows of her type is 1,150. There is my average. There's mu. That number goes right here. I'm tilting sideways to make sure I can see it. Always look for the average first. Okay, sweet. Now I use standard deviation. There's that 77. Now, again, definitely where to go. Relying on my calculator to help me figure out, 1150 plus 77. And then plus 77 again, and plus 77 again. Fill this out. 1227. And then do it again. Plus 77. 1304. Plus 77. 1381. All right, 1 standard deviation above, and then 2, and then 3. And then we go minus. So 1150 minus 77, 1073. Minus again, 996. Minus again, 919. You guys feeling pretty good about being able to set those up, draw those out, mark them off? Cool. Now, all right, just so I feel kind of good about where I'm at, where is the number that we're kind of looking closely at? All right, there it is. There she is, literally, the cow. She's weighing in at 825, and it didn't happen again, but on purpose. But like there, like way down here, right? Somewhere kind of. Now I don't know if it's right there, or if she's a little bit closer right here. But she's less than 919. She's in that what? That 0.15% section, right? Super, super small compared to everybody else. And that's what I want to do is I want to compare her, and the super easy way to do that is to do this z-score. Okay? Value, 825. So again, I'm hoping for like negative 3 point something at least, right? Negative 1. So this is 0, the average. 1 plus 2 plus 3, minus 1, minus 2, minus 3 standard deviations away. We're less than that. Let's see. So minus the average, so that's 1150, over standard deviation of 70. Now you can put it all together at once. I like to kind of take my time and put the tops together first, just to make sure I'm plugging this in my calculator right. Okay, cool. So negative 325. So the order obviously matters because negatives versus positives are going to be on one side of the mean versus the other. If you have a negative z-score, you're less than the average. If you have a positive z-score, you're above. Okay, cool. So then negative 325 divided by 77. Oh, yeah. Okay, so negative 4.220779, blah, 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 blah. You don't really have to write that out. What we do have to do is round it. And we're always going to round to 2 decimal places. So that's kind of where my brick wall is, right? The negative for sure, the 4 for sure, the point, the 2, and then I have to figure it out. Do we keep that as a 2, or should we bump it up to a 3? Well, we always look at the number right after. 5 or above, give it a shove. Well, that's just a 0, so we are good. Negative 4.22. So that means she is way down here. Like that is how many standard deviations she is away from the average. So she's tiny compared to everybody else. How tiny? That tiny. Statistically, that many standard deviations. Now we can use that. You'll see tomorrow we'll get into table A, and we'll find that and like put her in a percentile. Like how tiny is she really? Is she the 1%? Is she the 5%? So what do you think, folks at home? Somebody speak up. Is this going okay? You can just drop it in the chat, or you can unmute yourself. Does this stuff make sense?
Yes.
Okay. So turn to that second page then, and knock it out. I'll do it too, but I'm not going to talk through it nearly as much. I will just start putting up some answers as we go, so you can check to make sure you can start doing this on your own. I might cue you through a little bit, so we're feeling okay. But the process is relatively simple. Once you get the hang of it, you're in pretty good shape. So I'll be able to fit 1 and 2 in this space. So I'll just start knocking them out. But you got 1, 2, 3, and 4 to try yourself. Calculators for sure to help you add and subtract. But again, and I'll ask you this before we start, what's always in the middle? The average. Find the average first. Put that in the middle. And then what are you adding and subtracting over and over again? The standard deviation. Good. All right, so there it is. And then you look for your one value. And again, if you want to do this, you want to be like, all right, I think I know where that number is supposed to be. Right? That's where 75 is, right? Just a little bit to the right of 74. And so if you got if you get a z-score that's like negative 30, no way, I'm way off. Or if you get a z-score of 5, no, it's like over here, right? Remember, every tick mark is like a +1, +2, +3, -1, -2, -3. I should get something less than 0, but bigger than -1. Hopefully, let's see. Value minus average over the standard deviation. So I'll come down here. So -0.8333, right? And that just keeps going. So show me your rounding by doing that little squiggly equal sign just for your final answer. 2 decimal places always. I like the leading 0 right there, so I don't lose sight of the fact that it's negative 0 point something. That makes sense. Negative 8. Sure, cool. Negative 83. Right? To the left, because it's negative, but not super far, because 75. Right about there. Perfect. 1.7. 1.7. That works. So leave that up for a little bit, and then I will do 3 and 4, and then we'll be good to go. You feel pretty good with it? Not too bad, right?
Hey, Rosie.
Yeah, what's up?
Can we submit it if we're done with it?
Absolutely. If you are done and you want to submit and get out of here, you are good to go. You should be able to upload it to Canvas, get it submitted, and I will see you next time. You're good to go. Super easy. I like it.
Okay.
Thank you, Rosie.
Yeah, you're welcome. Thank you.
Have a good day, Mr. Rosengren.
Take it easy. See ya. Should I do 3, 4?
Hey, Rosie.
Yeah, what's up? Go ahead, what's up?
So I am in Texas and I have like no way of printing anything out.
Okay.
Is there any way I can turn all of this in by Friday?
Yeah, that's fine. Can you at least see the notes like as we do it? Like, can you like get onto Canvas
Yeah.
and like pull up the PDF? You just can't print it. Yeah, that's fine.
Yeah.
I think it might
Like
be.
I can pull up all the
it's-
notes.
If you want to like you don't have to rewrite all the words, but if you want to like hand draw out all of the like the curves and like just like draw them out and then do your z-scores,
Okay.
that's fine. You don't. If you want to get it done, so you don't have to wait until you can print it and then have to do it all at once.
Yeah.
If you want to kind of knock things out day by day, you can just sketch it as best you can.
Okay.
Right. So just kind of putting like that mean right down the middle with the dotted line, and then 3 tick marks to the right, 3 tick marks to the left. Don't worry about it being perfect, but just
Okay.
putting the numbers underneath, and then calculating the z-score. Then you can just upload that instead.
Okay.
If you want.
Do you have
Either-
lesson 3?
Say that again.
Do you have lesson 3? That's the only one I can't find.
Yeah, if you go onto Canvas, I put it in there this morning. I don't know why it didn't upload before, but if you go to Canvas and you go to assignments.
Okay. Wait, let me see. Okay. Yeah, there it is.
You should be able to find it right there.
Okay. Thank you.
Yeah, and the thing about lesson 3 though is that I didn't record Friday accidentally. So if we need to like talk through that one again, I did at the beginning of this one, but but maybe some of the questions as part of lesson 3 you might not be able to do as well if you don't know exactly what's going on. So I'm happy to kind of fill in those gaps with you sometime like outside of class. So if you have any questions and you want to reach out and you have some free time, I can go through lesson 3 with you anytime you want.
Okay, thank you.
You're welcome. Pages right there. You see, I'm starting to get into the habit of finding that spot. I think that's a good habit to get into because we're going to start doing that, saying, okay, where do I want to be? Where does that fall? Okay, 80 is kind of like right there. Obviously, it doesn't have to be perfect. Yeah. But when you're done with this, you are done and you are good. Sure. What did I do? 150, not 50. 100. Like something's off there. 100. Negative 2.7. Perfect. 0, -1, -2.7. Good. Average is 67. Standard deviation of 5, so 77. 57. Fill in the gaps. 82. What do we want? We want Z-score for a temperature of 68. 68. Oh, that's really close. This Z-score is going to be tiny, like 0 point something. It should be 0.2. 0.2. Let's see. 68 minus 67 divided by 5. 1/5. There it is. 0. It is 0.2 standard deviations. And that is it. Lesson 4 done. Nice. Standard deviation, then the curve, then 68, 95, 99.7, and now this. Good? Sweet. I'm good. I'm gonna stop recording because we are good. So if you are at home, of course, stick around and finish up if you need to, but you are good.